Now to the calculus for parametrics. So the first thing we need to look at is how we're going to find derivatives. So if you look at the first derivative of a parametric, so that is simply dy over dt. And then we have dx over dt on the bottom, because if we were to cancel out the dt's, we would end up with dy over dx, which we know is our slope, or our first derivative. So it's a little different when we look at the second derivative. Second derivative is the derivative of the derivative, which we've always done for any function that we've looked at. The difference here is at the end, what we need to do is divide by the dx dt. So the derivative of our x equation always has to go on the bottom, and that continues on for third derivative, fourth derivative. We just keep dividing by dx dt. Okay, it's just the way that we're going to get our dt's to cancel out and end up with only x's and y's. So when we look at example 4, we're given an x, we're given a y, and we're going to have to find first derivative and second derivative. So the first thing I would like you to do is take derivative of your x's and your y's. So I'm going to do dy dt. And once you're comfortable with this, you can really skip this step. But we're going to do it right now. So derivative of y, so 3 derivative of sine is cosine. And then we're going to do our dx dt. dx dt, so derivative of our x equation is, so derivative of cosine is negative sine. So now that we've taken derivative of both of our equations, so now we can set up our dy dx. So dy dx is simply putting our derivative of y over derivative of x. So we get 3 cosine over negative sine. And we can go ahead and simplify this. So cosine over sine we know is cotangent. So this is a negative 3 cotangent. So that would be our first derivative. So it's pretty straightforward. Just gets a little tricky to remember the process for second derivative until you get used to it. So the next thing we need to do, so to find the second derivative, we need to take the derivative of our first derivative, which the derivative of cotangent. So it might be easier for you. Well, it's faster to know what the derivative of cotangent is, but if you forget, you can go back to this cosine over sine, and you could do the quotient rule. Most of you know the quotient rule. I know you do. So you could find the derivative that way. It just takes a little longer. So derivative of cotangent is negative cosecant squared. So we're going to go ahead and write that. So negative cosecant squared. So that would turn the, sorry, let me rewrite that. That would turn the 3 into a positive. So negative cosecant squared times negative 3 would be, oops, I meant to have a t there, sorry. And then we have to divide by dx dt. So this is where this comes in. So the negative sign goes back underneath here. So negative sign. And now we can simplify this. We remember that sine is 1 over cosecant. So we could divide 3 cosecant squared by negative 1 over cosecant. We could flip and multiply, and that would turn out to be a negative 3 cosecant cubed. Now, if you prefer to do the changing the cosecant squared into 1 over sine squared and doing it that way, then you would have negative 3 divided by sine squared, or sine cubed. You could do that too. I just think this looks a little cleaner without the fraction. So that's how you find second derivative. So in the past, just the number one mistake by people is they always forget to divide by that dx dt. So make sure you're doing that. All right, example 5, find slope and concavity. So we know slope is referring to first derivative and concavity is referring to the second derivative. So we're doing the same thing we just did in example 4, but with a little slightly different information. And we need to go a little bit further with our answers. So finding slope, so first thing we're taking first derivative, so we can go ahead and we can take the derivative of y, so dy dx. So if you think it'll be helpful to list out the dy dt and the dx dt like we did in the last example, go ahead and do that. I'm just going to jump right to this. So we're doing derivative of y. So that would be 1/2 t divided by, so t to the 1/2, that would be 1/2 t to the negative 1/2. So 1/2s cancel, and t divided by t to the negative 1/2 power, we could move that to the top and become positive. So we have a 1 power and a 1/2 power added. So we're going to end up with t to the 3/2. Okay, so there's our slope equation. Now we need to find the actual slope. So how we do that is there's added information given. So t is greater than or equal to 0 at the point 2, 3. So we need a t value. We know it's greater than 0. We need to take this x and y values, find out what our t is. Okay, so here's an x is 2. So what we could do is grab that 2, plug it in for x, find the t. You could also take 3 as a y value, plug it into your y equation. Whatever's easier, you're going to choose. I personally think it's going to be easier for us to use the x. So let's go ahead and plug that in. So 2 is our x, so that's equal to root t. Square both sides. So we end up with 4 as our time. So time is 4 at this point. So now we have a t value we can plug into our equation for slope. So 4, so our slope is 4 to the 3/2 power. Now you could type this in on your calculator and get an answer, but if this is the non-calculator portion, you would have to know how to handle the radical exponents. So you could take 4 to the 1/2 power, which is square root of 4, which would be 2, and then raise it to the 3rd power, which is 8. So slope is 8. So now doing concavity, we have to do the next derivative. So okay, so second, oops, the wrong button here. Second derivative. So remember, we're taking derivative of this. So derivative of our derivative would be 3/2 t to the 1/2 divided by our dx dt. So 1/2 t to the negative 1/2 power. So 3/2 divided by half would be 3. And then t to the 1/2 divided by t to the negative 1/2 is just t. So there's our second derivative. So second derivative we're going to take, and we're going to take our time and we're going to plug it in. So 3 times 4 is 12. So concavity is 12. Okay. So 12 being a positive number, we could say that this is concave up. All right. I'm actually going to cut this video. I'm going to make another video to finish out the lesson.